compare rational numbers. So this time, instead of comparing integers only, we will already encounter comparing fractions and decimals. Just like before, when we compare, we're gonna use a symbol greater than, meaning the ones on the left part has a higher value compared to the ones on the right. And when we use less than, meaning the ones on the left has a lesser value compared to the ones on the right. And equal sign if in case both values are just the same. So let's have our first example. We have here negative 2.7 and 4.4. So going back to our lesson during module 1, we have a number line. So it would be best to understand this if we will look into again number lines. So the ones in the middlemost again is 0, and the ones in the right are positive numbers, and the ones on the left would be negative numbers. The more that you go to the right, the more the value becomes greater. And the more you go to the left, the more that your value becomes lesser. So looking at the two numbers here, one is negative, one is positive. So negative 2.7 must be here on the left part of the 0. So it could be somewhere here. And 4.4, 4 is here, then 1, 2, so the 4.4 is somewhere here. It's positive, so that's why we're here on the right. So looking at the location of 4.4 and negative 2.7, 4.4 is on the right part of the number line, while negative 2.7 is on the left part. That means negative 2.7 must be lesser than 4.4. Just remember all the time, negative numbers are less than compared to positive numbers, because you see the negative on the left and the positive on the right. But let me just try to revise the given. What if it's 2.7 and you are asked to compare 4.4? Both are positive. That means that you can use this method like you would locate the numbers on a number line. And you just check which one is on the rightmost, and that would be the number which is greater. But if not, you can just align the decimal points. So 2.7, we align the decimal point of our second number, which is 4.4. And you'll begin on the leftmost part. If we look at the leftmost part, the first digit before the decimal points, if you compare 2 and 4, 4 is greater. So that means 2.7 is less than compared to 4.4. Let's look at another example. What if we have negative 6.7 and the other one is negative 6 and 3/5? That means that we're comparing now a decimal with a mixed number. For you to compare them, we can convert negative 6 and 3/5 into decimal. So, negative 6 and 3/5 is the same as negative 6 plus 3/5. Now, there's no such thing as fifth place. So, it's either we make it into a multiple of 10 or use long division. In our case here, we can actually multiply 5 with 2, and whatever you do in the denominator, do the same thing on the numerator. Why are we multiplying a 2? Because if you multiply 5 with a 2, you will get 10. 3 times 2 is 6. So this is already 6 tenths. That means that the 6 is in the tenths place. So negative 6.1 place value for tenths, then that would be 6. That means you're comparing negative 6.7 and negative 6.6. Now, since both are negative, so this would be something else. The ones on the rightmost, again, should be greater compared to the ones on the left. If we just stick to the usual way in grade school, 6.6 and 6.7, if you compare them, 6.7 would be greater compared to 6.6. But since we have negative signs already, that means it's the other way around. If both become negative, that means that negative 6.7 now is lesser compared to negative 6.6. Why is it that it's the other way around? If you look at a number line, if we're now in 6, negative 6, this is negative 7. The concept of decimal is dividing a whole into 10 because both of them are in tens place. So we're dividing this one into 10 equal portions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is negative 6. So we'll have to figure out which is 7 so that we can locate negative 6.7, negative 6.7, negative 6.1, negative 6.2, 0.3, 0.4, 0.5, 0.6, 0.7. So this is now negative 6.7. We'll figure out where is negative 6.6. So negative 6.6, negative 6.1, 6.2, 0.3, 0.4, 0.5, 0.6. If we compare them, negative 6.7, you see it in the left portion of negative 6.6. That means this is lesser compared to negative 6.6. So our final answer is less than. Let's have another one. If both given is fraction, you can actually convert them into decimal and you can compare them. But if you would want to stick to the given, compare them based from the given fraction, you can actually compare them. How will you do that? We can do cross multiplication. So 4 over 7 and then 3/8. Cross multiply 8 times 4. So that means it is 32. Then 7 times 3. Then that means it is 21. Comparing 32 and 21, 32 is greater than 21. That means that we can conclude that 4 over 7 is greater than compared to 21. I mean 3/8 because 32 is greater than a 21. But be careful about doing this method. For example, for this one, if you have numerator multiplied to its number across, that's where you will put its product. And here, if you multiply 3 across it is 7. The result, you would put it also here as a replacement, 21. And you compare. Okay, take note, just be careful. If the givens are negative, that means it's the other way around. You can do the same thing but disregard the negative sides. So 4 over 7, 3 eighths, 4 times 8 is 32, 3 times 7 is 21. 32 is greater than 21, so do not be tempted that negative 4 over 7 is greater. It has to be opposite because take note, both are negative numbers. So that means it's the other way around. So negative 4 over 7 is less than compared to negative 3 eighths. Okay, how about this one? We have negative 4 thirds and 5 tenths. So of course, this item is very easy. Why? There's no need for you to do cross multiplication. This one is negative if you notice, and this one is positive. And remember, positive numbers are greater than a negative number. So, negative 4 thirds is less than 5 tenths. Because this is negative, this is positive. Let's have our last example. So looking at this one, the given is actually negative 4 fifths and negative of negative 7 over 8. So take note, what will happen if in case you see this kind of situation? That means that you can actually divide them or multiply them if you want to. Negative times negative, take note, that will become positive. So we can simplify negative of negative 7 over 8 as 7 over 8 because negative times negative is positive. And this item is already easy because negative numbers are always lesser than a positive number.